In 1997, the first case of human infection with avian influenza viruses has been reported in Hong Kong. Since 2003, the laboratory reported and confirmed in the total number of 309 infected human cases. 188 people were reported dead. The symptom of avian influenza in humans is fairly similar to typical influenza-like symptom. Severely ill people will develop respiratory diseases, pneumonia, and even life-threatening complications.
There are two key proteins on the surface of influenza virus particle, namely hemagglutinin and neuraminidase. The H protein helps the virus particle to attach to the sugar receptor on host cell. From recent instances reported by WHO, the H protein of avian influenza A virus has been evolving. Soon it may be able to bind to the human receptors.
In April 2006, a collaboration of Academia Sinica Genomics Research Center, Academia Sinica Grid Computing Team, and European laboratories has analyzed 300,000 possible drug components against 8 different target structures of influenza A neuraminidase using the EGEE grid infrastructure.
Deal with scientific research of even greater scale. What one needs is a way to integrate resources on demand or at will. Such requirements from scientists have been growing in the past few years. Through the global collaboration, scientists is capable of managing large-scale research in a more effective way. Such a new research paradigm is called e-science. Grid computing is currently the most feasible way to provide solutions for e-science infrastructure and application.
The global grid infrastructure could allow scientists to submit their data for analysis via PC, no matter where he or she is. Then the resource broker accepts requests from users' jobs, assigns them to the most appropriate computing elements, logging and bookkeeping their status of progress, and finally retrieves their outputs. To ensure the availability and the reliability of the grid resources, all job execution and data transmission status has to be closely monitored by the grid monitoring system. The worldwide LHC computing grid, WLCG, the world's biggest application grid, is being established to store, manage, and analyze the unprecedented amounts of data. For high-energy physics, tens of millions of gigabytes per year. Building on WLCG's experiences, the European Union e-science flagship project, Enabling Grid for E-Science, EGEE, deploys G-Lite middleware and infrastructure to support large-scale research and cross-disciplinary programs in other areas such as biomedical atmospheric science and earth science applications. By 2007, EGEE has integrated the equivalent of 50,000 of today's PCs from over 241 institutes in over 50 countries into a computing and data grid system. For the docking of 300,000 compounds against 8 different target structures of influenza A neuraminidase, 2,150 computers were used during 4 weeks, the equivalent of 137 years on a single computer. The significance of these results not only manifested the fact that global grid infrastructure could speed up data analysis, it also demonstrated its capability of integrating global resources on demand and providing immediate supports.
Grid computing was originally designed for the large-scale data analysis needs of high-energy physics. The so-called WLCG Global Infrastructure Worldwide Large Hadron Collider Computing Grid was developed to meet the requirements. The core essence of WLCG lies on the global collaboration and resource sharing. In order to serve the scientific community, one must be able to integrate the globally distributed resources in a prompt way and to provide the stable, reliable, and convenient services.
Avian flu drug discovery is one of hundreds of different applications from many different scientific disciplines that are running on the EGEE grid today. Grid technology has permitted a 6,000% increase in productivity in identifying potential new drugs.
With the advanced grid technologies, GRID provides efficient, convenient, and reliable services on resource integration and massive data analysis. No doubt, GRID creates a new research paradigm which will lead the future scientific research into a whole new direction.